Hello everyone. Today in this video I will be discussing about one dimensional parity check, and here before proceeding with the parity check, first of all you need to keep these terms in mind. The first one is parity bit. Now parity bit means an extra bit which is added to every segment of data before transmission. Okay. Now after adding the parity bit, we can have two situations. The first one is even parity and the second one is odd parity. Now even parity arises when the number of ones is even, okay, and odd parity arises when the number of ones is odd. So this will be of great help in our parity checking. And another term is there, that is errors. Errors means changes in the bits that form the data segment. Okay. Now errors can be of two types: single bit error and burst error. Now single bit error, as the name suggests, it means change in only one bit of the data segment. Okay. That is, let's say a data segment has 10 data bits. Now change in only one bit among the 10 bits, that leads to single bit error. And burst error, when there is change in 2 or more than 2 bits, then that is known as burst error. Okay, so let's proceed with the one dimensional parity check. Now, in parity checking, first of all, we need our data. So let's mention the data first. So let the data be 110010. Okay. So first of all, what we will do? We will just count the number of ones here. So the number of ones is 1, 2, 3. So number of ones is 3, that is odd. Okay, so that is odd. So now what we will do, we will write the parity bit that we need to add here. Now there will be two approaches for us. The first will be even approach and the second one will be odd approach. Now first one is the even approach, that is we will consider even parity. Now since here is 3 number of ones, that's why for making it even we need to add another 1. So our parity bit will be 1. Okay. So finally the data with the parity bit becomes 1 1 1 0 0 1 0. Okay. So this is our data that will be transmitted. This one is the parity bit and this one is our data, original data. Okay. Now this has been transmitted. Okay. Now if this is transmitted in the exact way that is now here, then we will get no error. Okay. If this one is exactly transmitted as it is now, then we will get no error. But if while transmission this changes to, let's say, 1 1 1 0 1 1 0, okay, if the data changes to this, then what we will see, previously our number of ones was 1 2 3 4, okay, but now the number of ones is 1 2 3 4 5. So previously it was even, but now it is odd. That means there is an error. Okay, so this was I proceeded with the even approach. Now let's see the same thing with the odd approach. Now for the odd approach, what we will change here, first of all this will change to odd. Then what we will do, we will change the parity bit. Okay. So let's change the parity bit. Since there are already 3 number of ones, that is odd number of ones, therefore our parity bit will be 0. That is, we need not to add any extra 1. So here it will be 0. So this will be transmitted. Now if this exact data gets transmitted and received as well, then we will get no error. Okay, but in case this changes to, let's say, 1 1 1 0 0 1 0, if this changes to this one while getting transmitted, then we will get error. Okay, so this was our one-dimensional parity checking. Now there is a limitation to this one-dimensional parity checking. What is that? The limitation is that it will not work for multiple errors. That is, if there are cases of burst errors, then this parity checking technique will not work. Let's see an example. Let's see here only. In this example only I will show you. Okay. Now let's change this bit and this bit. Okay, we are moving on with the odd approach only, odd parity approach. We are moving on with that only. So we are changing this bit and this bit while transmitting. Okay, so it will become 0 1 0 0 1 1 0. Okay, so previously how many ones were there? There were 1 2 and 3 ones. Okay, now let's check. It's 1 2 3. So previously also there was 3 ones, now also there are 3 ones, but you can see that this data and this data, they are completely different. But in our one-dimensional parity check technique, it will not be recognized, and hence this will be regarded as a no error. Okay, so this is one of the limitations, an important limitation of this technique, which needs to be kept in mind. And for that, to eliminate this limitation to some extent, we use the technique of two-dimensional parity check that we'll discuss in the next video. So thank you guys. Stay tuned to my channel for my next videos, and if you are new to this channel, then please subscribe to my channel, like the videos, share them with your friends so that these videos might help your friends. Thank you.